Hi, welcome back to Advanced Artificial Intelligence. This is Tariq Rashid. Today's class is two parts. The first part, as always or most of the time, we go through theoretical part of algorithm, and then the second part, we will explain or we will provide a practical example on how we can implement this algorithm. So today's algorithm is called adaptive boosting or AdaBoost. This is part one, and I'm Tariq Rashid. So adaptive boosting definition, it's a foundational ensemble learning algorithm in machine learning, which combines weak learners into a stronger classifier. That's a basic definition. And more definition on it, it's an ensemble learning method that combines multiple weak learners, usually decision stump, okay, which builds a strong classifier by repeating and focusing on difficult samples, which adjusts the weight of training samples adaptively and improves performance by focusing previously misclassified instances. So by emphasizing on or focusing on previously misclassified instances. So the idea is learn from mistakes by increasing focus on hard examples or samples. Now, historical background, this idea was coined in 1995 and developed in the framework of computational learning theory, which builds on the concept of boosting, earlier explored in theoretical machine learning. The contribution of this work is that a collection of weak learners can form a strong learner under certain conditions. Who invented AdaBoost? Well, it was Yoav Freund and Robert Schapire. They contributed to a theoretical foundation of the boosting and proven that weak learners can be boosted into an arbitrary accurate classifier. Schapire later on won the Ensemble Turing Award in 2023 for this great achievement or milestone. Now, theoretical view, weak to strong learning, which assumes a weak learner performs slightly better than random guessing, binary case accuracy greater than 50%, and combining many weak learners, then we can construct a strong classifier. So mathematical formulation, there is a training process. If we are giving a sample or data sets x1, y1, x2, y2 until xn, yn, weights will be initialized from these samples, and weight error can be calculated through this error. Weight error can be calculated through this. That's the weak learner not equal to y, and the weight will be multiplied by this one. So it's a sigma. It's a sum of all weights, whereby they have errors. So weight of sample I sample, and we classifier at iteration t. Now, importance of each weak classifier, we need to find alpha. Okay, and alpha can be found by this formula, which it needs error to be plugged in. So if we have error is small, then classifier gets higher weight. And if error is large, then classifier gets lower weight. Now, Updating samples can be done in this way. So when we found alpha, we plug it into this equation and we multiply it by the current weight, then we will get weight for the next iteration. So misclassified samples leads to weight increase. So once we have misclassified samples, it means that weight increases. Correctly classified samples, it means that we have less weight. The normalized weight after that. Now, a strong classifier can be considered in sign, alpha, weak classifier, and sum of them, and then the sign of it. So that's the final prediction, is a weighted vote. So a strong classifier, it's a combination of many or multiple all weak learners. So some of the advantages of AdaBoost is that focus on hard to classify samples, reduces bias and improves accuracy, works best with simple models, decision stump, and sensitive to noisy data and outliers. In conclusion, we try to convert weak learners to strong learners. That's the main idea. Uses adaptive weighting strategy, so the weight will be adapted to each iteration. You'll have a different weight from the current weight. Well, repeatedly, we try to improve classification performance and foundation of many modern ensemble methods. So this is more or less about today's class, and stay tuned for the practicals, which is also important to see how this beautiful algorithm can be implemented step by step. Thank you very much and stay tuned.